Hello, we'll be doing our presentation today on PyMol. My name is Andrea.
My name is Monica.
My name is Kavya.
My name is Mona.
My name is Esmeralda.
And my name is Marcy, and I'll go ahead and explain what PyMol is. PyMol is a software used in computational chemistry to visualize the 3D structure of protein and the molecular structure. PyMol has 3 panels. The top panel is the upper control panel that contains the command line that can be used to communicate with the PyMol. The middle panel is the displaying area where you can be able to see and manipulate the structure of the protein. This panel is the object menu panel, which shows all the list of objects that are displayed in the displaying area. This section is the mouse control, and the last row is the moving control.
Thank you, Mercy, for the introduction on PyMol. I am Esmeralda, and I will be showing you how to upload the PDB file onto PyMol. So what you're going to want to do is go to the PDB website and type in your PDB code. Ours happens to be 1A9S, enter, and then you'll get information about the protein and the specific residues and ligand that interact with the protein. We're going to go ahead and go to download files, go to PDB format, and as you can see, the file has been downloaded onto my desktop, and now we can go to the program to upload it. You can either go to File, Open, and search through your folder to find the file, or you can go to the upper control panel and type in fetch and the PDB code and enter. And you will have your protein displayed in the cartoon version.
So to pull up the amino acid sequence, just click on the S icon at the bottom right of the PyMol viewer. And then you see a long line of letters and numbers above it. So the letters indicate the one letter codes for amino acids, and the numbers above them indicate the positions of these amino acids on the protein chain. So for example, this T over here is the 1 letter code for threonine, and the 6 above it indicates that this threonine is on the 6th position of the protein chain. So if you right click here, and you can change the color of this to whatever you want. And if you right click again, you can show as sticks, and there's your amino acid. Similarly, if you look at the Y over here, this is the 1 letter code for tyrosine, and it's in the 7th position. And you can do the same thing. You can change the color, and you can show them as sticks, and there's your tyrosine.
To find the ligand, you're going to scroll the sequence all the way to the right. Your ligand will be presented in a 3-letter code. In this case, it is NOS. Keep note that there is a possibility that there are more than one 3-letter code. To see which one is your ligand, check the PDB website.
Hi, so I'll be describing what the tab on the right means, as well as what the colors mean on the cartoon and stick representation. So we have the 1A9S molecule displayed on PyMol right here. So on the right side, you can see the letters A, S, H, L, and C. So A stands for action. When you click on it, you can see that it stands for action. S is show, H is hide, L is label, and C is color. The drop-down menu for A is often used to zoom on a specific amino acid or ligand. So let's go over to the ligands. I'm going to click on S sequence, and I'll be choosing NOS as our ligand. And if you want to zoom in on this ligand, all you have to do is click on A, and click on zoom. If you want to zoom out, you can click on A for all, not the selected, and click on zoom. You can also use this tab to rename your selection. I'm going to be renaming this to NOS 290. Now for S drop-down menu, you can see that this is a tab for how you want your molecule to be represented. In this course, we're going to be either using cartoon or stick representation. Basically, you want your whole molecule to be represented as cartoon, while the specific ligand or an amino acid you choose is most often represented as a stick. So what I'm going to do is go to S for all, click on cartoon, and for NOS 290, we're going to go to S show and click on sticks. And if you zoom in again, this is the stick representation of our ligand NOS 290. For H, the drop-down menu shows the option of hiding. So if you click on hide everything, you can see how the ligand is now gone. And you can display it back by clicking on S and clicking on sticks. In this course, we usually use this tab to hide water. So what you want to do is click on H for all and scroll down and find waters. And now the water molecules disappeared. For L, this is the tab that you use when you want to label your residues, your chain segments, atoms, and so forth. So if we want to label our residue, click on residues, and now we can see that it has been labeled NOS 290. And if we want to label the atoms, we click on atom name, and you can see the name of the atom as well as their numbers. And if you want to clear all the labels, click on L and click on clear. And last but not least, C drop-down menu shows how we can change the color of basically anything. So in this course, we're mainly going to be using by element. And you can see that O is oxygen, which is red, sulfur is orange, and nitrogen is blue, hydrogen is white. And this basically just changes the color of the carbons. So you should use this when you are showing the interaction between two residues, and it's always a good practice to distinguish between the two by making their colors different. And if you want your whole ligand to be the same color, you can basically choose anything from here. I'm going to choose salmon, and your whole ligand NOS 290 is salmon colored. So that was a basic tutorial on how to use the tab on the right.
So the simplest way to change the background color is by going to display, background, and changing it to whichever color you want. So for the purposes of this class, usually white is the preferred background color whenever you're going to submit a lab report or a project. So you click on this and change the color to white. Now to change the quality of the image and make it better, you go to display quality and maximum quality. And as you can see, it's less pixelated and the quality is much improved. And to show double bonds or resonance, you can type set valence, comma 1, and that changes all the double bonds and resonance, as you can see.
We will now discuss as to how to properly make measurements between your ligand, shown in yellow, and one of the amino acids found in your sequence. Head over to Wizard, click on Measurements, click on one of the atoms from your amino acid, and click on the other atom from your ligand. A measurement has now been made of 3.3 angstroms. To save this measurement, click on Done, and if you would like to change the color of the dotted line of your measurement, head over to Measurement, Color, and pick your preferred color. This has now been changed to black. Please do remember the hydrogen bond should be between 2.5 and 3.5 angstroms. Van der Waals nonpolar steric or pi stacking should be between 3 and 5 angstroms.